Hello everyone, this is Philippine from pantechelearning and I welcome you all for engage your learning experience with pantechelearning anytime, anywhere and any places. We are always supporting to the students in a technical way. What is our main vision? We are going to help 10 million students to learn the technical knowledge by the easy way. And I welcome you all in today's session of Artificial Intelligence Masterclass. Today, we are going to discussing about one of the interesting topic in deep learning, that is drowsiness detection system. That means driver drowsiness detection system. So this is very important for the safety purpose. This is very important for the safety purpose. For example, now the technology of artificial intelligence will help many more things for the human. For example, it will be helpful for the safety purpose as well. Safety purpose as well for the, avoiding the, accident. These are the things. So, with the help of the deep learning, with the help of the computer vision, we are going to build driver drowsiness detection system that can be possible. Okay, right. So, without delay, I'm going to discussing about the theoretical part. After that, I'm going to, explaining about the, how to train the model as well as the how to, testing the model as well. Okay, right. So what is the introduction of this particular project? That is very important, right? So first of all, in this project, we will be making the drowsiness detection system. So here the number of countless of the people driving on a highway road day and night. Okay, day and night. Maybe that the taxi driver, bus driver, truck driver, and people traveling a long distance suffering lack of sleep. So that will be making a accident. Okay, that will be making accident. So lack of the safe it will be making, right? So due to which is becoming a very dangerous to driving when the feeling like a sleepy. Okay, when feeling like a sleepy. So in this particular project, when the driver is going to feel like a sleepy or when feel like a drowsiness in this, that time the system will intimate to the driver you are going to sleep like that. Or otherwise, it will be making an alarm to what is that? Alarm to intimate to the driver you are going to sleep. So that is actually very dangerous. So if you are using this particular system, it will be going to avoid this particular unwanted things like accidents. So the majority of the accident happen due to the drowsiness of the driver, right? Because of the lack of the sleep, definitely automatically it will be feels like a sleepy or a drowsiness. Okay, so while you are feeling like a drowsiness, and this is why we are going to drive with a drowsiness, that is very dangerous. So we should avoid that. Okay, that is we should avoid that. So prevent these kind of the accident. We will build a system using the Python, OpenCV, as well as the Keras, which is like alerting the driver when he feels like a sleep. So what is the main important things of the particular system? When the driver is going to feels like a sleepy while in a driving, that time the artificial intelligence technology will help to intimate to the driver or will help to like alert to the driver. Okay, that is the system. Okay, that is the system we are going to build. Okay, we are going to build. So drowsiness, like drowsy driver alert system. So what is that exact meaning of that? So drowsiness detection is a very safety technology purpose of the, like this kind of avoiding the accident. So that can prevent the accident that are, caused by the driver who feel like a sleepy while in a driving, right? So what is the objective of these particular projects? So for example, it is like, to build the drowsiness, detection system. So it will detect a person, is going to feels like a drowsiness while in a driving. That time the alarm will intimate. So that is the objective of this particular project. That's why I mentioned here. So it is the Python project. We are going to build the drowsiness system. It will detect that person's eyes closed or open. Once it is closed, in this definitely the alarm will intimate to the driver. Once it is open, in the sense that is not a problem. That is not a problem. Once he feels like it's sleepy or he feels like drowsiness in the sense that then automatically the eye will be going to down and closed. in this particular system, it is going to focusing on the eye. The person, I mean, like the driver, eye is going to close, I mean, in a certain time in the sun, alarm automatically will ring. Okay, right. So that is the system we are going to use. So that's why I mentioned here. So that it will detect that person's eyes closed for a few seconds in the sense the system will alert the driver when the drowsiness is detected. For a few seconds, definitely it is nothing but the drowsiness of the driver. For example, here we are fixing the 15 seconds. Okay, 15 seconds. That means depending on the counting, after 15, the person is definitely he feels like a drowsiness. It will be going to, alert to the driver. Okay, so that is the system. That is the objective of these particular projects. So what is the objective? So we are going to build drowsiness detection system. That means it will be detected. A person eyes is closed in for a few seconds. Then the system will alert the driver when the drowsiness is detected. That is the objective of this particular project. What is the next thing? About data set. So we need the data set to drive, build like a model for this particular project. So what are the data sets we are going to use? The data sets contains 2,900 images, which is included both normal and drawing images. Okay, drawing images is like, that is also a symptom of the, like drowsiness, right? Or feels like, symptom of the sleep. So data set is divided into the training as well as the testing, which is used for the project, for the training as well as the testing respectively. So without delay, I'm going to show that particular folder, then only you can understand easily about this. Okay, you can see here, this is the data set. And this is for the testing purpose and training purpose. And training here, this is for, opened eye images. You can see, so this is the images we are going to use to training the model. So the computer can't understand. It is not, easy task for the computer. So we should training the computer with the help of the certain image for the eye open and eye closed and the eye yawn, images and non-yawn images. So you can see here, this is the opened, this is the opened eye data set for the training. And closed, you can see here, and this is the closed thing. Okay, this is the closed. So this is the purpose of the training. Okay, this is the purpose of the training. Yeah, you can see here now. So this is the closed images. And one more thing, Noyon. So this is Noyon. Okay, so this is normal. This is very normal. But yawn in the sense, you can see here, yawn. Now you can understand, right? So this is a symptom of the sleepy. So why the driver is driving in the sense that time he feels like yawn in the sense that is also symptom of the drowsiness, right? Yeah, you can see here. This is actually for intimation, for the helpful for alerting, and it will be helpful for training the model. Okay. Right. So these are the data set we have. The image, this particular data set consists of the 2,900 images for training and testing purposes as well. And you can see here, what about the testing purpose here? Yeah, this is the same thing. You are also going to use the same thing for the testing purpose. Okay, right. So this is about the data set. Okay. So what is the, the model architecture? The model architecture and CNN model architecture layer we are going to discuss. How to train the model for this particular task. Because with the help of the open eye picture, with the help of the closed eye picture, with the help of the yawn and no yawn picture, so it will be helpful to training the model. Then only the computer can understand, yes, it is open and yes, it is closed. Once it is closed in this, definitely the driver is going to feels like a sleepy, so alarm will intimate depending on the eye closed for a few seconds. Okay, right. So model architecture. The model we are used is built with the Keras using the CNN. Normally, the Keras is working on the TensorFlow. So TensorFlow is nothing but the Keras backend. Okay, right. So a convolution neural network is a special type of the deep learning. So already we knew this because we were discussing about the many things related to the particular task with the help of the CNN, right? So already we knew this. So basically, the convolution in a one line, convolution neural networks explanation in one line, it is going to extracting the features from the image, and it is help to, returning the output based on the features. So that's why this is the very important types in deep learning. So that's why I mentioned here. So which is performed extremely well for the image classification process. Most probably it will be helpful for the image classification. How it can be possible? Because of the convolution neural network is basically extracting the features from the image. Based on this feature, like based on these features, it will be helped to detect. So here also the feature extraction is very important based on the eye open, based on the eye closed, based on the yawn, based on the non-yawn. So it will be returning the output like, yeah, the driver feels like sleepy or whatever it is. Okay, right. So the convolution neural network is a best algorithm for this particular image classification process. Okay, right. So normally the CNN it having the multi layers to training the model. So already we knew this. That is convolution 2D, maximum pooling, and convolution 2D, and fully connected layers, and fully connected layers, and the flattening. These all are the layers we are going to use to build the model. So here you can see here. So CNN model architecture layer here, we are using the convolution 2D layers. So that will be, we are fixing the 32 filters. It will be returning the 32 features in that particular each and every features. So based on the features, it will be returning the output like, So that's why we are fixing the 32 layers. And the kernel size is defaultly 3 by 3 or 5 by 3, whatever it is, as your wish. So, and convolution 2D is again we are going to creating the convolution 2D. Again, we are going to creating the convolution 2D. Once you are going to fixing the multi layers inside the model, it will be performing very well. So that is the reason we are going to create the three different the convolution 2D layers. It will be help to improving the performance of the model. And you can see here I'm going to use the like 32 nodes for the each and every layers. So it will be help to returning the 32 filters of that particular images, 32 features it will be getting from that particular layer, and it will be help to for defining the output. Okay, right. So based on the features. And fully connected layer, I'm going to use the 128 layers. So it will be connected to the, based on the features, it will be returning the output. And the fully connected layers, here I'm using the, two different things. The output will be like, binary. So once it is a binary or single output in the sense, you can use one or two. Okay, so this is the output layer of that particular, this is the output layer of this particular model training purpose. Okay, right. So without delay, yes, what is the prerequisite for this particular project? So we need to know about the OpenCV, TensorFlow, Keras, and Python. So Python will helpful for the, to play the alarm while the eye is closed in the count of, less than 15. Okay, it is not getting alarm. So after greater than 15, it is going to start the alarm. Okay, right. So OpenCV is helpful for phase and eye detection. That is very important. Because the phase detection after that is going to eye detected in the sense that time it will be returning the based on the eye open and close it will be returning the output. So that means we need eye detection. Okay. So we are going to focusing on the eye. So we are going to training this is for the testing purpose. Okay. So this is for the testing purpose. What about the TensorFlow? So Keras is uses the TensorFlow as a backend. So Keras is helpful for the building a model for the classification program. Okay, and Keras will retain the model, Keras will retain the layers. So using the Keras, we are going to get the model sequential as well as the layers. Okay, fine. So this is the prerequisite for this particular project. What's the next? Yeah, the steps. What are the steps we are going to follow? The driver drowsiness detection system, we have the 5 steps. The first one, take the images as an input from the camera. We are going to access in the camera too. Okay, so we are going to detecting the real time, accessing the real time. So real time process. So I will show the output for this. Okay, right. So now detecting the faces in the image and creating the region of the interest for the face. So region of interest in the sense it is the rectangle box. It is a rectangle box for the detecting the face and detecting the eye from the region of interest and feed into the classifier. Why we are going to feed into the classifier for the only eye? Because of based on the eye, it will be returning the output. Otherwise, it will not. Try to understand. So once you are going to detecting the face, after that we are going to concentrating on to detecting the eye. So based on the eye open and close, it will be returning the output. So once you detecting the eye, so that particular region of interest we are going to feeding into the model prediction. once you are going to feeding that particular eye detection, so based on the eye open and close, it will be returning the output. Once the eye is closed for a few seconds, and suddenly it will be going to alert to the driver. Okay, right. So that's why I mentioned here. The fourth point, classifier will categorize when eye open or closed. Okay, then calculate the score to check whether the person is drowsy or not. So based on the score, the person is drowsy or not. Okay, right. So before that, we need to classify the category, the eye is open or closed. So that's the classification. After that, based on that, the calculate the score to check whether the person is drowsy or not. So these are the process we are going to discuss. The first process. We are going to use the CV2 dot video capture. It will be getting from the OpenCV. So this is the computer vision function or image processing function to access the camera. So video CV2 dot video capture. So it will be going to accessing the camera. Okay, accessing the camera and set the output for the object. So that will be we have to read the frame. So if it does not read the frame, in the sense we can't find the face or eye. Okay, so what is the next step? Detecting the face and detect the face in an image and create the region of interest for the face detection. So we will use hat classifier. So this will be helpful for detecting the face and eye. So this will be more helpful. So it is the pre-trained model. It is actually pre-trained model. Okay, right. So face is equal to CV2 dot hashtag classifier. So this is the XML file we need. Okay, XML file we need. I will share to you. Okay, this XML file is needed. It will be help to detecting the face. So once you initialize this one, it is going to finding the face and the faces. Once you are going to initialize this particular variable to store the value for that particular file, then detect multi-scale will returning the like detection process for the face. And it is returning the detection of arrays, for example, x coordinate, y coordinate, and height and width. That is height and width for the boundary boxes of the object. Once the base is detected, it is going to create the boundary box based on the x coordinate, y coordinate, and width and height detected face. Okay, it is going to detect. Why we are going to use the x coordinate and y coordinate and h and w? So based once it is detected, we need height and width to detecting and creating the region of interest. So based on the width and height, it will be creating the region of interest. So that is the reason we are going to use. So these particular function to initialize and loading the value for this particular file. After that, this particular function will returning that particular what is that? Phase detection and to the arrays detection with the help of the x coordinate and y coordinate and the height and width for the creating the region of interest of the face. What is the next? Yeah, detecting eye from region of interest and feed into the system. So we will be using the Haskell classifier to detect the eye for the left eye and also the right eye. For the left eye, it having the function. For the right eye, it having the function. So left eye is equal to left eye dot detect multi-scale of the gray. And it will be help to extracting only eye data from the image. Try to understand. It help to extracting the only eye from the full image. Once the face is detected, now we are going to iterating over the sequence for detecting the face detection. After that, it is going to detecting the eye. So for the left, it will be extracting the only eye data from the full image. Then we are going to found the focuses of the eye. Then it can pull out the eye image. Then it will be feed into the CNN classifier, which will predict the eye open or close. But it's a step 4. The classifier will categorize whether eye closed or open. That is very important, right? So it's a CNN classifier to predict the eye status, but it exact the character dimension. So, okay, right. So, or this is for the right eye. So to converting the picture into the grayscale and resizing the image. Okay, resizing the image for the expected size or target size. Then I is equal to we are going to normalize the value of that particular image. Then we are going to loading the model like this. So load model and I predict for the left and also the right. The same procedure we are going to follow. Once the one detected the value 1 in the sense open eye and 0 in the sense closed eye. I will explain the coding, then only you can understand easily. So while I'm taking the theoretical with this, then maybe that little bit of confusion. So I will explain. Okay, so finally, this is very important. Based on the eye open and based on the eye close, calculate the score to check whether the person is drowsy or not. So the score basically, your value will be used to determine the how long a person has closed the eye. Okay, how long the score is based on the how long a person is, has closed his eye. So that is very important. We both, when both eyes are closed, the score will be increasing. Greater than 15 in the sense that time the alarm will increase. So if the eye is open in the sense suddenly the score will be decreased because of the eye is going to open. So normally once you are going to open in front of the camera, the score will be 0. One you are going to close and this is automatically score will be increase. When it is increase greater than 15 in the sense that time. So that's why I mentioned here means the eye is closed for a long period, the alarm will start to beep with the help of the sound dot play. I will explain, then only you can understand easily about this. Okay, right. So without delay, first initially we are going to training the model. That is very important, right? So first model training I will explain. Okay, model training I will explain as the same procedure. The same procedure for creating the model. The first import the necessary libraries. So here, OS will help to accessing the path. Okay, the OS will help to accessing the path, and from keras dot pre-processing the image. Okay, so it will be help to pre-processing the image, and matplot.pylot PLT, then numpy. So this will be helpful, and keras utils. So this is to the categorical, and this is for the model, and this is for the layers, and this is for the load model. Okay, right. So here it is not needed actually. So it will be helpful for the testing purpose. Okay, right. Yeah. So now define generator. Okay, define generator. So here we are going to, preparing the images, to, rescaling the image, and the size will be, we are going to create the target size will be, you can see here 24 by 24, I think so. You can see here 24 for 24, and class model is a categorical model. You can see now categorical model. So without delay, I'm going to explain to start about this. Yeah, okay, right. So now we are going to create one particular function. So this is the direction and generator. So image data generator. So this will be helpful for the pre-processing the image or rescaling the image divided by 250. Okay, this is the batch size and target size we are going to mention here. After that, this return will be generated dot flow from directory. This is the direction. Then batch sizes, and the color mode is a grayscale. So we are going to converting the color in that particular loaded images. So this is for the data generation. Okay, data generation. Now, so this is for the function of this particular process. So we are going to decide. So what are the things we are going to follow once you are going to loading the model? This all of the processes is going to convert. For example, the image will be rescaled. Okay, the image will be rescaled, and target size will be converted. The image will be converted into the, reshaping into the 25 for 25. Then the color will be changed. So that is the color mode here I mentioned grayscale. Okay, so what are the changes will be happened here? That means target size will be happened, and the color mode will change. Like PGR into the gray, and yeah. So these are the things we are, done with the help of the image data generator and rescaling the image as well divided by 250. It is the nothing but the normalizing the image. Okay, nothing but normalizing the image. Okay, now this is the batch size, and this is the, like target size. So this 25 by 25 and 32 batch size. Okay, then training data and testing data. That is training batch and testing batch. This is the variable that is user defined. Okay, then you can call the generator. So this is the direction you can replace that particular, trained data. So you can see here, yeah. So this is the data set, right? So you can access this particular path. Okay, you can access this particular path, just copy and paste there. That's it. Okay, so this is, data new train. Okay, so what is our, data here? Data new, and here the data new for the valid or test. Okay, what is the name we are going to use? That is test folder, right? So you have to mention here like, test. Okay, this is the testing purpose. This is the testing purpose as well as this is for the, training data, sorry, testing data, and this is the training data. Then batch size is 32, target size will be 25, 24 or 24. Okay, now we are going to, batch dot classes. Okay, then this is the, training purpose, and this is the, the size of the image. Okay, then we are going to initialize the, sequential model, that is sequential of convolution duty. This, so we are going to create inside the model to creating the layer. So how to do that? The convolution layer and to maximum pooling layer, then convolution layer, the maximum pooling layer, then convolution layer, maximum pooling layer, then dropout, flatten, and dense, and the dropout, flatten. Sorry, dense. Okay, you can see here. So this is the convolution layer. So initial layer, the first layer, we have to initialize the input shape. So that is already target size 24 bar 24. So we have initialized here. Then activation function is relu. Then kernel size 3 by 3. Then this is the 32 filter. It will be returning the 32 features in each and every images. Then maximum pooling 2D. So already you knew this, the particular purpose. It will be returning the, necessary and needed features from the image. So what about the, remaining things? So that is the negative features that we know, we don't need that actually. So it is going to ignore that, but it will be the maximum pooling 2D will returning that necessary, features from the image. Okay, then convolution 2D, again, we are going to create the 32 filter, and 3 by 3 is a kernel, then activation is equal to relu. Then the same thing, the maximum pooling size. Then again, we are going to create another layer of the convolution 2D, then maximum pooling 2D. Okay, then randomly we are going to turn the neurons and off to improving the convergence. So dropout 0.25. Then flattening, it will be converted to changing the dimensions to reducing the dimensions. Okay, right. So because of our classification, output will be like 1. So that is the reason 2D into the 1D we are going to convert. Okay, then fully connected, get all the relevant data. Get all the relevant data. So fully connected layer will help to, finding the output based on the features, it will be written that. Then output, we are going to use the softman because of it is the, classification problem. So this is the output will be the probability. Okay, because we are going to rescaling the image. So probability will be the 0 to 1. Based on the value 0 or 1, the eyes will be open or closed. We can understand easily. So tense, the layer, the output will be 2. The activation is the softmax. Now we are going to compiling the model. Now we are going to compiling the model. It will be helpful for, deals with the hardware for training and validating the model. So here optimizer is D for the Adam. The loss is the categorical cross entropy. The compilation after, before create, after building the model. Now we are going to compiling the model. After that, we are going to training the model for the training data as well as the, validation batch and approaches 15 and the test steps per approaches already we initialize. So this is for, you can see here. So we initialize already steps per approaches, and this is for valid batches. So you can see valid step, the validation step, that is VS. So already we mentioned what is the range of that, you can see here. So based on the length of the classes, so based on the length of the classes we initialized here. Okay, right. So training batches, so based on the images it is going to train. Then going to save the model. The model name will be CNN cat2.h file. Okay, once you run this in the sense, it will be saved in the model. You can see here. Yeah, this is the model folder. So it is saved. Once you run this in the sense, Okay, it will be saved in the particular directory which we mentioned here. That is model dot. Now the training process is completed. The model is trained. Okay, so model is trained. The model will be saved in the models. Directory. Now we are going to validating the model. So that is very important, right? Yeah. So import the necessary libraries. So now we are going to validating the model. We are going to, create the, accessing the real time, access. So import the CV2, then import OS we need. Then this is, Keras model. That load model will help to do that. Then import numpy and pygame is very helpful for, play the alarm. So timing. Okay, all right. So here we need to initialize this particular, timing, for the alarm. So mixture dot initialize, then sound is equal to mixture dot sound. This is the, file name. Okay, this is the file name. Then we are going to, for the deduction, for the phase deduction, for the, left eye deduction, for the right eye deduction. So CV2 dot cascade classifier. So we are going to using the hair cascade classifier for face deduction, hair cascade classifier for the, eye deduction. So what are the files we have? You can see here. So you can see the folder here. Yeah. Hair can classify file for the left eye and right eye for the, face. For the face deduction file, for the, left eye deduction file and right eye deduction file, for the, XML file. Okay. So initialize that and provide that particular location of the file. So CV2 dot cascade classifier for the face deduction, that is frontal face, XML file. Then left eye split XML file. Then right eye split XML file. Okay, for left eye, for right eye. Now it is going to initialize. What is the label that is closed and open based on the eye? Okay, now we are going to loading the model. So with the help of load model, then models, then CNN cat2.h file. So already we have that particular file because of the trained model. We trained them. Okay, right. So now path is equal to os dot get route. Okay. So now so initializing the camera to accessing the camera. So with the help of CV2 dot capture. Okay, CV2 dot capture of 0. Here I'm going to changing the camera ID. Why? Because of it is, I'm going to use two different camera, one for the light and another for the, what is that? Another for, camera access for the output. Okay, right. So here I'm going to use the 0. Then font style. Okay, font style we are going to initialize. So this is initially the count is 0 and the score will be 0. Okay, score will be 0. This is for the, R prediction and R prediction. This is the range. Okay, this is the range. Okay, then this till 99 it will be going to run. Okay, so we are going to fixing the value because of the score, because of the score. Why? Now I'm going to, initialize the while loop for iterating over the frame. Okay, so when the condition is moved to the false, that time only it is going to terminate. So we are going to reading the frame. So capture already we initialized. Now we are going to reading the frame with the help of cap dot read. Okay, then height and width. Okay, height and width of the frame. Okay, height and width of the frame. Now we are going to taking the value for the height and width on the frame shape. Okay. Now we are going to converting the frame color conversion. That is a gray, because of the model is expecting the grayscale. So it will be working properly and smoothly. So that is the reason. So normally in computer vision, we are going to convert the grayscale for the certain methods to processing on the image. So this one single channel is expecting that. So once you are going to convert the grayscale, it is converting the single channel. So once you are going to processing on the images, it will be very easy and it will be going to find the object in that particular images is in the easy way. So there is a reason the grayscale is expecting. Okay, grayscale conversion for that particular frame. Okay, this particular frame. Now, phases deduction. Okay, now we are going to phases. So already we initialize the phase and left eye and right eye, right? So now we are going to finding the phase deduction. So phase detect multi-scale for grayscale image on the frame. Okay, frame. So this is for the scale factor and minimum size to by 25 by 25. So this is the grayscale. Okay, for the this particular frame. So this is nothing but the detecting the face. It will be returning the detecting face. And this is for the left eye detection. This is for the right eye detection. The same thing we are going to follow. That is detect multi-scale. This function will return the detecting the left eye and also right eye and the face. Now CV2 dot rectangle on the frame based on the height, based on the like it will be returning the that particular what is that region of interest it is going to create. For for now we are going to iterating over the face. Okay, iterating over the face. So based on the x coordinate and y coordinate, based on the height and width of the detected faces, it will be creating the region of interest. So you can see here for x coordinate, y coordinate, it is going to find, and based on the height and width of the face detection, it will be creating the rectangle on the particular face. That is nothing but the region of interest. So for this is the iterating variable and this is the sequential variable. Once the base is detected, it's going to iterating over the x, y, w and height. So it is going to find that getting the value for the height and width. So this will be helpful to find and creating the region of interest on the detected faces. So CV2 dot rectangle frame x coordinate, y coordinate. So x plus based on the height of the face and based on the width for the face. And this is the color range. This is the color range, then thickness will be 1. Once the base is detected, the rectangle box will be going to display on the detected face. Now we are going to iterating over the right side. Okay, iterating over the right side. Okay, so x coordinate, y coordinate, and w that is width and height. H is a height. So it is going to iterating over the right side now, the frame. Okay, so Ri, okay, Ri is equal to frame of y is to y plus height and x is the x plus width. So now we are going to count plus. Okay, count plus, it will be increasing the count. It will be increasing the count. Then or I, that is right size to converting the grayscale, then resizing the image and rescaling the image, the value will be converted into the 0 to 1. Okay, already the value will be 0 to 255. So we are going to convert and normalizing the image 0 to 1. So that is the reason we are going to divide it by 255. Then reshaping the image to 24 by 24. Okay, then expanding the dimensions. Now we are going to model prediction. So R predict. So np dot arc max, np dot arc max, this is nothing but the prediction. Okay, this is nothing but the prediction. So model dot predict for the Ri. Okay, Ri in the sense right eye, the axis 1. If the prediction is equal to 1, that is nothing but open. If the prediction is 0, that is nothing but closed. Okay, if the prediction is 0, that is nothing but open. If the prediction is 0, that is nothing but the open, closed. So based on the value, probability and value. So for the same thing for the left eye. So for the frame, the count will be increased. And you can see here for the left eye, converting the color PGR into the gray, then resizing the image, then normalizing the image. So normalizing the image in the sense that a value, the arrays will be, range will be 0 to 1. Then reshaping the image, then expand the dimension, then model prediction. If 0 is 1, the index will be 1 in the sense that is open. Then if it is, 0 in the sense that is closed. Okay, now we are going to increasing the score. Okay, you can see here if R predict and L predict is equal to 0, you can increase in the score. Okay, you can increase in the score 1 plus 1. Okay, because of it is closing the probabilitical value, because of it will be returning the 0. Okay, it will be returning the 0. So it is not depending on the score. Try to understand that. It is not depending on the score, but it is, the value, probabilitical value based on the, 0 is nothing but the closed, 1 is nothing but the open. That is the value. So based on the value, the score will be increased or not. Okay, you can see here, or predict, okay, 0. is equal to 0. If both the things are 0, the score will be increased one by one. That means while you are closing your eyes in front of the camera, it is going to increase in the score. Then CV2 and put a text, then frame will be closed. The score is going to increase in the sense that time it will be closed. So height, and this is the where should display this. So at the end of the frame it will be displayed. So that is the reason height minus 20, then 10. So this is the default range to fixing the end of the frame. So this is the thickness. Okay, this is the thickness. This is the style. Okay, then this is the color. Okay, this is the color, that is white. Okay, else the score will be decreased. Once I open in this, the score will be decreased. 0 is nothing but the closed. Okay, then put the text, then it is open. The same followed. Where should we mention that particular notification? Okay, right. So you can see here, if the score is less than 0, the score will be 0. Okay, based on the probability value. And put the text, the score, and string, the same thing. Okay, once the score is increased or decreased, whatever it is, we have to put on the text. Then this will be the so go to saving the frame if it is needed. If it is needed, otherwise play the sound. Here, if the score greater than 15, play the sound. That is alarm. Play the sound. That is alarm. Okay, that is alarm. Otherwise it will not need. Okay, so you can see here CV2 dot rectangle, the frame. Okay, CV2 dot rectangle. Once, so this will be like once this particular thickness range, it will be greater than or below 16. Okay, below 16, the thicks will be increase. Otherwise, it will be decrease. Okay, the rectangle frame like this. Okay, rectangle frame like this. This will be the color for the alert rectangle. So this will be notification. This rectangle will notify the driver is going to move to the fields like drowsy. So that means based on the color, it will be the alert. Then cv2.im show, this is the frame. So once you click Q on this one, that time it will be going to terminate on that particular frame. Okay, right. Okay, sometimes one thing we have to understand, if the sound is not played in the sense, we are going to pass this particular color. Okay, it will be intimating the alert. So that means red frame will be detected. Once the score will be increased above 15 in the sense, that time automatically the frame will be displayed, in a red color. Okay, you can see once I run this, you can see, you can understand this rectangle will help you intimating the, alert. Now I am going to run this. Okay, now I am going to run this. You can see the output. Now I am going to recording the screen and also the recording the audio. That time, alarm will not ring. Okay, alarm will not ring. But definitely you can try it yourself. The alarm will ring. Now I am going to record it. So that is the reason maybe that it will not ring. Okay, because of the OS is going to access to playing the alarm. So I'm also going to taking the record in a OS only. So that is the reason maybe that it will not ringing the alarm. So now I'm going to display and run this code. It is going to accessing the camera right now. It is going to access the camera right now. Yes. Yet. Just a minute. Just a minute, guys. It will not display. What is the reason? I don't know. Yeah, you can see. You can see. Just a minute. Yes. Now I'm going to see the output. Now the score will be 0. Okay, the score will be 0. My eye is open. My eye is open. Okay, so because of the probability value 1. The probability value 1. So that is the reason now it is open. Once I closed my eye, the probability value below, 0.5. So it tends to 0. That is the eye will be closed. So based on this output, open and closed. So it is, based on the probabilitical value. Okay, probabilitical value. If the probabilitical value 0, then the score will be increase. If the probability value 1, the score will be 0, below 0. 0 or below 0. That is the, based on the probability value 1, the score will be 0. Based on the probability value or the notification close, it will be increased. You can see the output. Okay. Now it is open. Now I am going to close my eye. The value will be increased and it is going to alerting the red color. Just a minute, guys. Yeah. Above 15, it is 16. The score will be comes to 16 in the sense the red alert will come, right? Yeah. Yeah, red alert will come till the score will be 250. This particular, red color also increasing more. You can see, the thickness will be increasing based on the thicker. Okay, based on the thicker, it will be increasing. Okay, so now my eyes is open, the score will be 0. It is going to down. Okay, right. So hope you guys are understood about this. Yeah. One more time, I will run this and you can see the output one more time fully. Okay, right. Yeah. I'm going to run it again. I'm going to run it again. Just a minute, guys. I'm going to run it again. You can see the output. Now the camera is going to access. Yeah. Yes, the frame is going like. Now my eyes is open. Okay. Once I close, it will be displayed closed and the score will be increased and red alert, red alert will come. Now I am going to record. So that is the reason the alarm will not ring. Once you are going to try this code, definitely it will be ringing in your system. Okay, right. Now, my eyes is closed. The notification is closed. The score is increasing. Once the score, greater than 15 in the sense, automatically the frame will notify that rectangle is, red color, right? So that is the, that is like, it is alert. Okay. The score will be 72 right now. And it will be going to reduce. Okay. Because of my eye is open right now, it is going to reduce. You can see 47, 45, 44, 43 is going to reduce. Okay. So this is nothing but the alert. This is also nothing but the alert. You can see right now. You can see this. Now it is the red alert is gone. Right? It's gone. The score will be going to decrease and the score will be 0. Right? It's clear, no? The region of interest you can see here. The region of interest. The score I mentioned 100, 100, 100. So that is the reason it displays the gray scale, gray color. Okay, based on the value that is 100, 100, 100 in the sense. This color, this is nothing but the region of interest for the base deduction. Based on the eye, it will be displaced open. Based on the eye, it will be displaced closed. Based on the probability value. If the probability value 0 in the sense closed, 1 in the sense open. Now the probability value 1. Okay. So probability value 1 in the sense that time the score will be 0. Probability value 0 in the sense the score will be increase. Okay, that is nothing but the eye is closed. So that time, based on the duration of timing, it will be, what is that increase in the score? And it is going to detect the driver feels like drowsy or drowsy interaction. Okay, that's it, guys. So that's it. So this is the output for. So this is the output for our, drowsiness detection system. Okay, drowsiness detection system. Driver drowsiness detection system that can be possible while the driver is going to sleep. Okay, right.
You want to do the internship on data science technology. This is the right time, and this is a special offer to you for doing the internship on data science technology program. You can now convert this particular masterclass into the internship. So this is the right opportunity, and this is a special opportunity to you. Use this special opportunity to you. You want to do the internship on data science technology in this, and this is the right time. So what is the benefit of this particular internship? Why? Because of most of the people are expecting the quality. Most of the people are expecting, like, if I pay the money, what is the benefit of that? That is the human nature. Everyone is asking the same question. So I will say the benefit of this particular internship. Please keep it in your mind, and also please do join immediately right now. 30 days of live session of data science masterclass. This is completely free on YouTube. This will be accessible for participant as well as the internship. So what is the special offer for, like, what is the special benefit for the internship user? Recorded videos is accessible for the 90 days of each and every day's classes. You can learn more about this when you are going to, like, the pause and play options will be there in this. Of course, we can learn more about that. So 90 days recorded videos is going to be accessible for the internship user. And you can receive the 8+ source code for which is discussed in the data science projects. And you can receive the source code and also the presentation of that particular project as well. And you can learn more about this. You can build and develop with me. That is the special opportunity for the internship user. And 30 days downloadable presentation, you can get it for the only for the internship user. So what is the benefit of that? 90 days of recorded videos is going to be accessible, and 8+ source code, the project source code, you can get it if you are an internship user means. And downloadable presentation of each and every days of this particular class, you can receiving that. And also hackathon classes available for the internship user. And you can receive the confirmation letter which is get it from pantechelearning, and also you can receive the certificate, internship certificate, which is get it from pantechelearning. These are the major benefit of that. And one more thing, so everyone is expecting, for that is the human nature. I can pay the money, what is the quality assurance? I assure you that I don't want to make you disappoint you, because of I believe myself. So that is the reason I can promote my class, because I taken the several things in the right way for the data science technology. If you believe, you can do join immediately. If you believe, you can join immediately, because of I can pay for that particular money. That is a quality or not, that we have to ensure it. If it is quality means that will be worthy. Of course, I can pay for 1 rupee or 10 rupees chocolate. That will be good in the sense, yeah, the money is valid and also the product is very valid. So that is the expectation of the humans. That is the nature. I can understand. And I will tell you one thing, I assure you that for the quality of this particular internship program, and you can learn the several things in data science technology. I assure you that, because of I believe myself, that's why I can promote you to, learn this data science technology as well. If you believe and if you are interested, please do join immediately. The link is mentioned in the description. Otherwise, the link is shared in the comment box. Okay, if you're not finding in the comment box in the sense, please go for the description of this particular session and you can find it, and you can find the procedure to enroll this particular program. So how to enroll this? The link is mentioned in the description. Don't forget to joining this particular internship. This is the very valid money for the learning. This much of money, the quality content you can receive, because of I believe myself to sharing to you. This is my program. I can promote for my particular program. Okay, so quality wise, don't hesitate. Please do join. I assure you that you can learn more about the the data science technology concepts. Normally, we charge nearly 999 rupees. So use the coupon code TSA3. The discounted fee will be nearly 590 rupees. This will be actually packet money. So most of the people are spending the more money for the entertainment. For learning wise also, you can pay this much money for to join this particular internship. For the quality wise, I assure you that because of I believe myself. Okay, don't hesitate to joining this particular internship. If you are interested means, please do join immediately. You can learn more about that, and you can receive the the internship certificate which is get it from pantechelearning, and also the confirmation letter which is get it from pantechelearning. The link is mentioned in the description and also the link is shared in the comment box. Use this, please enroll it right now because of 3 days to finish this particular offer, because of the offer is available till this particular masterclass program is completed. After that only the price will be increased. Okay, this is a special offer for the participants for this particular program. So that is the reason we share the every day for this particular money. If you are not using this particular opportunity for the next day of after finishing this masterclass, it will be increased. Surely it will be increased. Okay, so you want to do the internship, please do immediately this much of money and this much of content and quality content. Okay, right. So what are all the projects? Credit score classification, stress prediction model, and also the social media's ads classification, groundwater level prediction, code analysis prediction, and drowsiness reduction by using the convolution neural network, chatbot creation, electricity price prediction for a regression problem. These are all the projects you can receive the hands-on practice, and also you can learn and you can build and develop with me for this particular project, and you can receive all the source code for this particular project and also the presentation as well. And you can if you have any doubt, you can contact at any time. Please contact 89255533484 and also just to send one single mail to this mail id philip.pedit@pantechmail.com. Okay, if you are interested, please do join immediately. Enroll this particular link, enroll today and use this particular link to enroll it right now. Use the coupon code TSA3 and the offer will be 590 rupees. Okay, so 3 days to go for this particular offer for this particular data science technology internship program. Okay,
Thank you so much. Explore your knowledge with us. We are always here for you to support you in a technical way. Thank you so much. We'll see you next day with a different topic in deep learning. Thank you so much, guys. We'll see you. Bye bye.